Quick addendum video. I'll allude to this in an email. Accidentally had the video of land sea breezes in video number 1. That must have continued on to an additional video and been playing some background music that basically drowns out my voice. So basically one slide that I'm going to make a video on here to supplement that issue, so feel free to watch this in lieu of the music in the first video. Here we're dealing with frictional effects, the idea that when we have smooth areas such as lake water, frictional effects are minimized as opposed to terrain when they start to become increasingly strong. And so when we talk about, say, areas of Lake Michigan, you may have air that's flowing towards Lake Michigan that is being slowed down due to frictional effects. Once it comes over the lake, it speeds up due to the minimization of friction before it starts to become slowed down again due to frictional effects over land. This can be quite important. If you have slower air moving into faster air, this is going to create near-surface divergence, which is going to result, as we know, in sinking motion. So say, for instance, this would be flowing from Wisconsin across Lake Michigan and into Michigan proper. You might have sinking air and clear skies in Wisconsin where this air is spreading apart near the surface. And when we have this basically devoid mass here, we're going to sink it in and fill it up, the idea that we have conservation of mass. So the air becomes faster over the lake, but then we converge. The idea again of cars starting to pile up on the interstate as we get a bunch of traffic. Slower cars are going to slow down the faster cars. And so what that ends up doing is surface convergence. And as we've already alluded to many times, difficult for the air to go into the ground, and so we're going to result in rising air. And so this is a pretty common phenomena. So I have here in the little bullet, considering northerly flow along Lake Michigan. Again, if you're not super familiar with geography, Lake Michigan is generally oriented north to south. And so on occasion we get flow that comes from the northerly direction and comes right down Lake Michigan, causes the air to speed up over the lake, almost a geostrophic type flow occurring at the surface, which may not make sense depending on force balances, but it's a localized effect. The fact that lake water is not going to induce much friction in your air. And so what we end up with is, as this air comes down the lake at a high speed, you'll get to the point where then it hits land and the air starts to pile up, and this can result in areas, say around Valpo, if the wind setup is proper, that we get this convergence that enhances lake effect snow downwind of the lake. And so frictional effects can be pretty darn important on these local scales, dealing all the way up to the mesoscale for more increased precipitation downwind of smooth features such as the Great Lakes. All right, that's all. Short and sweet.